Hey everybody, hope you're doing well. Want to give you a quick little tutorial here on part of today's lesson. So when you click in there, you'll notice that we have factor by grouping. So just check that out. That's part of today's assignment. And then you'll also have, I think there's some mixed review problems there as well. I just want to kind of take you quickly through factor by grouping. And then that way, hopefully that'll set you up to be successful on the few problems that we have there. So let's just do a quick little recap on some factoring skills that we're already aware of. If I look at this first, x squared minus 9, we've done a lot of these. We can recognize a difference of squares pattern, and here's my factorization. All right, looking at x squared plus 3x plus 2. So here we had two terms. Here we've got three terms called a trinomial. I'd have something like x plus 2 and x plus 1, and there's my factorization. Um, and then looking at something like this, a little bit different approach. And if you remember, when we did these, we looked for a greatest common factor, so GCF. And in this case, we're looking for what's shared by both. And if you looked here, there was no number or variable shared by either term. If we look at this scenario right here, no number or variable shared by every term that's in the problem. In 5x minus 15, we do see that both the first and second terms share a factor of 5. So if I take that out of each, 5x divided by 5 is x, and negative 15 divided by 5 is negative 3. And remember, that's just really kind of the reverse of distributive property. So then if I did distribute, there's my 5x, there's negative 15, and I'm right back to where I started. So we had some, different approaches that we took to factoring, and then we also don't want to forget about that idea of a GCF. And this idea of GCF is really going to help us out today as we go with this factor by grouping. All right, so factor by grouping. If you take a look, you've got four terms in this problem, and here's why they call it factor by grouping. What we're going to do is group those first two terms and then group the next two pairs of terms. So I wrote the problem right over here. There's that first grouping, and here's the second grouping. By doing this, I put myself in a situation where I'm maybe looking for maybe a difference of squares, but probably more importantly, looking for a greatest common factor. So is there anything shared between x to the third and x squared? So if I think about it, both of them contain x squared. So if I did x to the third divided by x squared, that just leaves me with an x. And then minus x squared divided by x squared would just be 1. So minus 1. All right, so that's kind of how this first grouping would factor. When I look at the next grouping, what's shared between 9 and 9, or 9 and negative 9, if you want to think of it in those ways, and 9 goes into both. So I could think of that as take out a positive 9, and that leaves me with 9x divided by 9 is x, and negative 9 divided by 9 is negative 1. All right, so we did a GCF of these two terms, and we wrote that out here. We did a GCF of those two terms, and we wrote that right here. And then now here's kind of the critical part. If you've done this factoring by grouping correctly, this quantity and this quantity right here should match. So if you notice, as I'm looking at this line of work, all right, here was the original line of work, and now as I'm looking at this, this first term right in here, it's all multiplication, has an x minus 1 in it. And this second term has an x minus 1. So really, it's kind of like what we did up here where we pulled out a 5. I'm going to pull out x minus 1 from each of those terms, and that leaves me with x squared plus 9. All right, and you might be asking, okay, well, where'd that x squared plus 9 come from? Well, here's the idea. If I'm factoring it out, then here's kind of what happens. If I take it away from this, and I take it away from this, the only thing that's remaining is x squared plus 9. That's my remaining piece, and that's what's going to make up that next grouping. All right. So that's really, kind of the idea. So I'll write that back in here. Oops, let's get rid of that. And I'll put the x minus 1s back in there so we can kind of see that. X minus 1. And then here we had that x minus 1 as well. There's a few things that maybe happen with this. Let's say, for instance, this would have been the -9 and this would have been the positive. If that's a negative, you always want to factor out a negative here. Okay. Think about if you would have taken out a -9, that would have left you with x plus 1, and this x plus 1 would not have matched that x minus 1. So you want to make sure that the GCF that you're taking out here is going to allow you to find those two binomials to be the same. That's really kind of the big key when it's all said and done. So then we'll just come down here and we'll go ahead and enter in our values that we came up with for our two binomials. So an x minus 1 and an x squared plus 9. X minus 1 and then an x squared plus 9, and type it in just like that. Now, would it make a difference if you went x squared plus 9 and then after that you had the x minus 1? Wouldn't make a difference either way. All right, so that looks good. Also, reminder, you can watch the help video, and then on yours, you'll see over here in the top right corner, there's that show example, and it'll show you kind of step by step, and it takes you through that process. So don't be afraid to use those resources as you are going through there. Let's try one more here. Yeah, let's try something like this. All right. So as I'm looking at this problem, I'm going to rewrite it over here. So I've got a little bit more room to work with. X to the third plus 3x squared plus 25x plus 75. All right. And, if I wanted to look at this right now, I think GCF, well, this has a 1, so there's not going to be a numerical GCF that comes out of there. This doesn't have an x, so there's no shared variable, so there's no greatest common factor to take out immediately. This has 4 terms, so when I see 4 terms, I'm thinking factoring by grouping. So I'm going to first group those 2 terms there. GCF, what goes into both? It's a 1 and a 3, so no GCF numerically, but x to the third and x squared, I could take out then an x squared. All right, x to the third divided by x squared gives me x. 3x squared divided by x squared would leave me with a positive 3. And remember, you could check this by distributing it back through. X squared times x is x to the third. X squared times 3 is 3x squared. All right, here's my second grouping. What's shared between 25 and 75? GCF would be 25. And then 25x divided by 25 is x. And then 75 divided by 25 would be 3. And then once again, there's our big key, that shared x plus 3. All right, so I've got x plus 3. And then what are my remaining parts? X squared plus 25. So x squared plus 25. Got a little carried away with the 5 there. All right, so we'll go ahead and enter that in. X plus 3. And then an x squared plus 25. All right, we'll submit. And once again, help videos are available to you. Sample problem over here to show the work step by step of the way. But hopefully that puts you in a good spot to be able to answer those questions.